Welcome back to the 2021 question B3. It's an axonometric projection question. So the image on the right shows a table tennis table. Figure B3. So B3 is our preview of it. Shows the incomplete trimetric projection. So trimetric, 3 different angles down here. Using the axonometric axis method of a similar table tennis, incomplete trimetric projection using the axonometric axis of a similar table tennis. Okay. The elevation and end view are shown in the required positions. So elevation and end view. Okay. A pictorial view of the table is also shown. So both here and here. Draw the axonometric axes X, Y, and Z and a scaling triangle ABC. So we'll break it down step by step and go through all of this. So we'll start right bang in the middle of the page with our point O, and we'll measure our angle of 110 degrees to give us our X and our Y, sorry, our Z and our Y axis. Middle of the page, so somebody here. It's going to be my point O. And 110 degrees, so let's measure a 110 degree angle there. Zero around to 110 degrees. Yeah, 110 degrees. Okay, so that's our y-axis and our z-axis. So our scaling triangle then is going to help us to find our z-axis. So if we measure out 50, right, from our y-axis, that will find us A, and then out 40 in the other direction. So just extend this on. We'll measure 50 in one direction, 40 in the other. And that is going to give me point A. And that is going to give me point C of my scaling triangle, which will in turn find the the x-axis. Right, and now to finish my scaling triangle, I want to go at 90 degrees to the axis. So let's see if you can make something. Just to double check, it should be at 90 degrees, but just double check it. Right, slide that. And right now here. Yeah, and that is at 90 degrees. Okay, perfect. So the drawing goes up. So that's B. So we've got our y-axis, our z-axis, and our x-axis. And we have our scaling triangle ABC. So complete. Draw the elevation and end view, and orientated as shown. Complete the trimetric projection. Okay, so I just need to draw my setup first of the planes. So project out all these in the direction of axis X. Make sure I'm doing this accurately. Okay, and parallel to my scaling triangle. Right here. And then we want to draw semicircles, so in order to do that we need to bisect this line. That is the projection of one of my planes. I'll do the same on the opposite side. So project everything out. Perpendicular. So a big part of these questions is setting up the question. Okay, and this particular here is worth 10, 12, yeah, nearly half a mark, so it's important to know how to set up these questions. It requires no massive understanding, it's just learning it. Like, if you understand it even better, but you can get away without understanding it. You get half the marks. So that is the projections of our axis or our planes. And now we want to draw our elevation and end view. So elevation is straightforward enough. So I measure my 70 out. And we got up 50. Up 10. Okay, and then over to my elevation. Let's see what we got. Okay, so I'll step up my heights first. Can use them in a while. So we got 25, 25, and 10. So we're using those heights. I'm going to zoom in here just to get us a close up there. Okay, and you can see here that that point there is going to be the center of that radius 50. Okay, so I'll get my radius 50. Come here. And those heights are marked out. Projecting across to find those various points. Okay, so we can see a couple of things. So this center line tells me that everything on this side is symmetrical to everything on that side. So whatever this distance is, or that particular distance is, it'll be the same out to here. Get that distance, swing it out, I can project that up. Probably would have been easier to do that up here. But while I'm actually going to draw that centre line. Okay, so let's draw in a couple more things. Right. I also have to project up to find that point and that point. So vertically up. So let's finish that off. First up is the net of the table tennis table, the actual table surface. I've got the supports there. Alright, so that brings me as far as having the elevation and end view, and then we want to complete the trimetric projection. Right, so I will start with the actual table tennis net. So that's the projections of it there. Here it is here. So everything projected back in the direction of the z-axis or the x-axis. Okay, and the direction of the z-axis or x-axis. It's my net, appearing as an edge view there. Let's follow back there. Okay, so that is a net. Vertical lines. Right, so that's my net. Next up, let's do the top surface of the table. I've already projected the edge view of my table back, so let's just project from the elevation here with my x-axis as the angle of projection. 1, 2. That is the top surface of my table. Alright, and next up we want to do the curved surface. Okay, so we need to establish points along that curved surface, and it's essentially, if we look at it, this is a portion of a cylinder. If we looked at all of that, that's a cylinder. So we've got some points already, but we need to find a few in between. I am going to suggest using these 2 points because we'll need them in order to complete those supports, and probably actually have to project on those as well. And we'll take another few, maybe one somewhere up here as well. And before we do that, I suppose I just want to talk about one small thing. When we find points along here, we need to find corresponding points in my elevation, okay? So end elevation. Elevations, end elevation and elevation both have something in common, and that is heights. Heights are common between them. So I am going to take distances going up vertically along that axis, and I'll use those same distances over here to find the corresponding points. So maybe 50, break it up. I think it's 50. So there's halfway there, so I'm going to go maybe 15, and I'll go 15 here also, or 10. So we've got heights at 15, 25, and another 15 up for that. I'm going to find those corresponding heights over here. If you want to be sure, you can transfer them like so, or if you wanted to go 10, 10, 10, 10, that's fine too. Right, so it's whatever works for you. I got my 25 corresponding height, and up here in corresponding height. And then to find, these are essentially generators we're creating. To find points on the edge over here. Project, project. I'll find corresponding heights on each side, so we don't have to take even more heights. Okay, so I'll just index these to make life easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, and down here we're going to have them. That's 1, 9 at the bottom level, 1, 9, 2, 8, 2, 8, 3, 7, 3, 7, 4, 6, and we've got 5 at the top. Projecting in line with my x-axis. One, 2, 3, 4, 5, project down, 6, 7, 8, and 9. And we'll project all of these then in line with the z-axis. That's my 1 on to 9 coming out. 1, 9. So that's 5. So 5 is back 2. 2, 8, 3, and here's 3 coming down, back, there's 7 coming down, got 4, 4, 6, okay, so let's draw a free-hand curve. 9 coming up 6. Okay, so that's the front edge, but you can even see there we're going to have a back edge as well. So we've got these heights projected down the back edge. Let's project on those ones. follow. So that's one point. We have a second point here. Third point. And fourth point. Okay, so it's important to show that exactly where it goes into the object. Okay, don't just make that bit up, you need to find exactly where it's going to be traveling to. We'll do the same down the opposite side, so one down, there, so that'll be our heavy line. Okay, and the last little bit then is we need to include our supports. Okay. So, position of my supports, I still need to project down. Making hard work of this one. So, putting that on top of the table. Got a point and a point there. And on the opposite side of the table, point and a point there. And we know 7 and 3 are points. So 3 joint. The position of the support there, and here's where the support going down. 7. And can we see the back? We can just about see what comes up. Yes, you can't see it back there. So that is the projections of our table, and let's just see what we have anything else to do. What we do. Trimetric projection is done. Last bit, determine the true length of the diagonal along the top surface of the table. So we've got a diagonal running across our table. Right, we want to determine it. So it's kind of like finding the true shape. So we can either project out this way, or project out this way. I'm going to use this side. So imagine we're almost like rotating it up. So that would be the length, okay, and then the overall depth or width of our table we can take from here, which is 70. Alright, so let's measure, just show our length, this distance. So an arc up here, just got half the page width, so I'll slide that down. Stand that up. Okay, so that's technically the true surface of the top of the tabletop. Doesn't matter where we show the diagonal, that way or that way, it's always going to be the diagonal. Supposed to correspond to what we're doing. So that's the true length of my diagonal. Okay, so that is the 2021 question B-3. Nice axonometric question, a bit long but at times, but definitely achievable to do within the allotted time on the exam.